Hi students, coming to the next topic, that is a lossless decomposition. So in the previous video I explained about a decomposition and the problem that arises when we decompose the table, problem with decomposition. So to overcome that, we will go for the lossless decomposition. Means even you decompose the table, the data that is present will not be lost. Okay, that is a lossless decomposition. Let me write the definition for this lossless decomposition. A decomposition, let us take the decomposition of relational R or R1, R2 up to Rn. These are the set of relations that are present in a relation R. Okay, a decomposition R1 up to Rn of a relation R is called lossless decomposition for R. Okay, we say this is a lossless decomposition for R. When we can say this is lossless decomposition if the natural join of R1, R2 up to Rn produces exactly the relation R. Then only we can say this is a lossless decomposition. So when we are saying this is a lossless decomposition, whenever we have done the natural join on R1 or R2 up to Rn, when you produce exactly the same relation what is the main relation table, then you can say this is a lossless decomposition. So for you have to get the exact relation, you have to follow some procedure to make the relation as a lossless decomposition. So here I'm just writing R, A, B, C. R is a relation with attributes A, B, C is decomposed. So decomposed into R1 A comma B, R2 A comma C. Okay. So whenever you decomposed, it should be recover. The recovered one is R dash A comma B comma C. Means this is produced exactly the relation. So here this is decomposed. After union, after natural joining these relations, you will get the exact relation. Thus, the R is equal to R dash. Then you can say this is a lossless decomposition. So now you have to follow some rules for lossless decomposition. Let me write this. Ensuring, how you can ensuring the lossless decomposition. Let's see this point. Let's see these points. How you can ensure lossless decomposition. Let's take the relation R, A1 up to AN, B1 up to BM, C1 up to CP. So these are the attributes, different attributes that are present in a relation. Okay, so then this relation is decomposed into R1, A1 up to AN, B1 up to BM, and R2 A1 up to AN comma C1 up to CP. So these are the two relations. This relation is decomposed into two relation. Okay. So these will be divided into two relation if it has to follow this condition. If A1 up to AN determines B1 up to BM, or A1 up to AN determines C1 up to CP, then you can say then the decomposition is lossless. So when we can say that relation that is divided into two relation, that is decomposed into two relation, is lossless whenever there is a functional dependence relationship exists between the attributes. Okay, so here this B attributes is depends upon the A attributes, then C attributes is depends upon A attribute. Then you can say the data that is present in the after reconstructing the relation, the data will not be lossless. So whenever this A determines B and A determines C, then the decomposition is lossless. Okay, now let us see the property of lossless decomposition. Lossless decomposition property. So let me take that. Let R is a relation and F, you can take set of functional dependence of on R relation, and you can take X comma Y is decomposition attributes, decomposition of R. Okay, then decomposition is lossless. When you can say decomposition is lossless? Decomposition is lossless if X intersect Y, Y intersection Y determines X. That is, so this is one condition, that is all attributes common on both X and Y functionally determine all the attributes in X. So whenever they say these attributes or that relation is lossless if X intersection Y determines X, means here that all attributes common on both X and Y functionally dependent on determining all the attributes in X, or X intersection Y determines Y. It means that is all attributes common on both X and Y functionally determine all the attributes in Y. Okay, so this is a property of lossless decomposition. In other words, you can say if X intersection Y forms on a super key of either X or Y, then the decomposition of relation R is lossless. Means whenever this intersection forms a super key on either of the X and Y, we can say that data is lossless. So this is about the lossless decomposition. Thank you.